the Sustainability Management Master's Program, you're answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact.
The Stevens Institute of Technology is proud to present the Hugo New Corporation Sustainability Seminar Series, co-sponsored by Geocentric Consultants, H2M Architect Engineers, Brown & Codwell, and BEM Systems.
Thank you. And thank you for having me. I thought about the topic, and before we got into it a little bit, I maybe lay a little groundwork for fun, right? The shaping of smart cities and microgrid infrastructure. Only at Stevens could that be an exciting topic. I like it. This whole idea of power and infrastructure, and we're going to get into it, but I always start out by thinking every couple of years people forget, and I was on the ride over here in a lift, which in and of itself is a relatively new technology depending on your view of the world, and I asked the driver, who was 24, can he ever remember a time without a smartphone? And he couldn't, because it's 11 coming on 12 years, right? It hasn't been that long, but relative to his life, it's been a long time. And it got me thinking about tonight and the framing of this, and so, as we talk about infrastructure, you all are addicted. I'm going to begin with addicted in such a way that I'm not sure that you even understand the addiction, and I'm not sure you understand what I'm talking about in terms of what you're addicted to, but I think you do. And it's happened recently, right? This idea of power controlling everything, right? In the day of a dormitory in 1980, there was a little TV that was plugged in. No one really had a computer. You went to a library to do that, and it's not that long ago, right? And the energy density, right, the amount of energy used in a place, a room, was relatively low. I look around now at the number of wires plugged in around me, and you begin to think about how that energy density has increased over time, and with the addition of smartphones and VCRs and then DVDs and cable boxes which sit on, and security cameras, and on and on and on, and you begin to realize, right, that from a day-to-day perspective, and I had asked the young man, have you ever run out of power in the phone? And the look in the mirror told me not just that he had, but he was irritated. Right, you could feel it, the sort of visceral reaction of it sucked. I ran out of power, right? This is the cord. We're all next to it and around it, and you can see them everywhere. And this is relatively new, and so I start there because I always think about whether people even at this level, at a fine esteemed place like this. You know how many people walk into a ladies' or a men's room and the electronic eye turns on the water or even gives you your paper towel? I dare to say there's probably only a small percentage of people who know how to manually turn the water on right now, or the paper towel holder. And I want you to think of who you are and who everybody else is, the non-engineers of the world, right? And think of that, right? We're so reliant that we can't even wash our hands without electric, yet we rely on an infrastructure, as I see the wire sitting over there with the pole bending at like 48 degrees, that is frail, very frail, right? And so, when we look at, how we get here and what people are dealing with, it's not just New Jersey. And I was here during Sandy, and when I say here here. I helped do work on the original design for the Hoboken microgrid, and it's one of the leaders, just like Stevens' microgrid and others, that are rethinking, and we're going to get into what that means, because I think people take this for granted, right? But I'm also in California a lot. I travel a lot. I was talking about that, and everyone's going through it, right? Their fires were our Sandy. They're rethinking about power. They're shutting off power to millions of people unannounced because they don't want to create fires during windy days. They're worried in California about sparking fires. I want you to think about your mother, your grandfather, your sister, who's having the heart surgery today, right? It's all like hypothetical unless you're in the blackout. And people are not used to blackouts, and then it's 4 hours or 8 hours, it's a hospital, it's something that's critical, and all of a sudden people are, wow, sewer, water, we'll talk about that. But you can see that there's this general waking up, and it's an awareness, and I don't know if anybody's Seinfeld fans, but I was a Seinfeld fan. George Costanza's worlds are colliding together, right? We've got nature and the environment, we have global warming, and we do, and we have changes in the environment, right? It's causing more pressure, more storms. At the same time, I started talking with, you have a reliance on technology, and it's not just you, right? It's fun when it's phones, and it is annoying when it's phones, but when you start to think about other stuff, fire, police, emergency services, pumps that carry water, right, that are critical, because places flood. You don't realize how many places just in New Jersey are built underwater, right? They have a pump system. So along comes this waking up. And what I love about New Jersey is we like to make fun of ourselves, but sometimes we don't take credit, right? It happened here, right? And Sandia National Labs, which is one of our, our national labs for the department, and it thinks about power and energy, and it thinks about all sorts of things from military bases, right? How to harden an island. If they lose power, how do you keep power going? And so they came here to Hoboken, right here, by the way, flew a jet in, all landed here, and came and worked on thinking about how this city could be hardened like a military base. And why? Well, you guys are up against water. You have these little things called paths and, little couple highways in case you don't notice your traffic around you once in a while. It was fun getting here, thank you. Maybe next time 7:30, not 5. And so there's there's this amazing congruence of things going on at the local level, police, fire, safety, communications, that are all reliant on energy. And when energy went out here, everyone went, wow, not only can't we talk to people, I want you to think about that. 911 was down. Police and fire, emergency services, like stuff that is significantly serious. And by the way, we're all nice people. And, if it's not so nice people, you don't want to let them know that everything's down, security's down, hotel stuff is down, cameras are down, all of it reliant. We couldn't get fuel in a car because we weren't smart enough to have emergency generators, because we never thought the power would go down to move the pumps, to move the fuel. It sounds stupid, but here we are like a decade later, and go look around, see if it's all hard. It's not. Hoboken has made great strides. Other cities are taking their first steps, but it is the beginning of two things. One, it's going from big to small. Guys, to me, this is where it happens, right? The revolution of jobs and industry and intelligence. Things are shrinking. It's not just nanotechnology and smaller phones, and you can make fun of my 40-pound one 12 years ago to today's little itty, but it's much more than that, right? We are rethinking power and energy. You're rethinking food. Indoor agriculture closer to the source. You're rethinking about how maybe solar and storage and other types of technology can bring you closer. I want you to think about the analogy for 1 second, because it's hard for people. Power is a commodity. If you put your hand out, and those at home put your hand out, if you can feel that electricity just bouncing off, right? It's a commodity. It is no different. Coffee is a commodity. Milk is a commodity. They are all commodities. They're bought and sold on a commodities exchange. They are treated the same. So how many people would voluntarily buy a $30 gallon of milk at a Target or a Walmart because it was $30 for 20 minutes a day? The rest of the time, it's a normal price. Energy works the same way. It's a commodity. It's bought. It's sold. You guys go in, and when you're buying your energy, and it's built in here today, you're getting around 30% of what you paid for. Why? Because the energy is being made miles away. Nuclear plants miles away. Gas plants, coal plants. And it's being transformed, and it's being converted, and it's going through all these systems. By the time it arrives, you're getting 30% of your milk that you're paying full price for. If you looked at that when you got to the register, wouldn't you be pissed that somebody just drank most of you? All right, but see, no one in America seems to question, right, that this is it. And not only that, but people don't understand the dynamic of pricing and how it works. And so along comes Hoboken. And along comes New Jersey, New York, Connecticut, and this whole reaction to Sandy that says, you know what, let's rethink it. Let's go from big to small. Let's begin to think how we can shrink power and how we can begin to think for police and for fire and for emergency services. I want you to think, how many people have multiple phone chargers in their house, right? You have redundant phone chargers. We have one wire, and go look at it. It's embarrassing, right? It's on a pole, and there's hundreds of them. It's not the utility's fault, right? Everybody wants power, but go look at what they look like. If you hit a pole with a car, you know what happens? The pole goes down, and the fire and police are connected, and so we don't have a backup other than a diesel generator that sometimes doesn't work. So we want to rethink, how do we get smarter? And how do we really take a system that's really been a one-way highway where we take power, and how do we begin to rethink it? And this is what's going on in the United States, from California to the Midwest to here. It's not just microgrids, but it's the evolution of what they call smart cities. Because what they're thinking about is, how do we take that big macro experiment and begin to take three things. One, how do we take critical facilities, our police, our fire, our pumps, not just that, but hotels. Where do we store refrigeration if we need it? Other folks that are in a public-private partnership that allow them to make sure they have power. So we're thinking about that because we're so reliant on it. Number two, anybody knows STEM? And the conversation about that, this is the fun part. People have STEM conversations, and all these new industries are coming in. Data centers, if you haven't seen the data center, oh my golly. So they're all here. What do they all need? Incredible amounts of power. Not just power, but quality of power, right? And so all of that is happening. I'm going to add one more to there that I'm missing from that slide, although you're going to see it later. Something else is about to add itself to that sector. You guys know what it is. I took an Uber here tonight. It was a hybrid. Want to bet what the Uber looks like in 5 years? Bet you it's not a hybrid. Bet you it's all electric, right? So you're going to absorb the entire transportation sector, one that has stood on its own, not just this, cranes, trucks, buses. You guys like to shop on. It's all going to be absorbed into this electrical system. And so electric development and how we do it is becoming a significant key industry, and how we make buildings and other things self-sufficient, right? How do we take the big power and move it so that we can continue to grow, because you guys want jobs, but not grow in a way that continues to demand the same system. And then finally, quality of life, right? At all levels, I'm going to talk about this evolution to a smart city. The idea that power and intelligence are going to run next to each other from now on. 5G and power, by the way, one needs the other, in case you missed how it actually works. And so they need each other. And so we're going to add intelligence, because I want you to remember, what has power? Every building have power? Police, fire, every pump, everything that you, traffic lights, do they have power? Street lights. Think about the level of control if you have intelligence in the power system. You can roll fire trucks that instantly talk to streetlights, correct? They can all turn as the truck is moving. You can have intelligence. You can actually communicate in a way that allows the system to react. And you're going to hear that over and over, and because it can't react without power. It just cannot, right? And it's still, and I hope you guys invent the way to do it without the wires, it still works a particular way in how it gets to places. And so, as I said, we have one more piece of this. We're going to add transportation. And I like this slide, but it is missing something as well. Anybody know Port of Elizabeth, Port of Newark? It's a monster, right? People don't realize it's, I believe, although we're on some sort of live thing, I believe it's crossing in to be one of the biggest. It used to be number 5. Rumor has it might be very soon, which is great. The Bayonne Bridge got raised. There's economic development. There's a lot of commerce going on. But I want you to think they used to have all these diesel cranes, and these cranes lift incredible amount of weight. If you've ever seen what they do, they're like literally lifting these cargo containers in heavy wind off ships, moving them onto straddle carriers that move them onto trucks. They get sniffed for nuclear, and they get looked at and radared, and it's an incredible process that goes on thousands of times a day. And just in that one terminal, just one terminal on the port, and there are 4 or 5 of them out there, just in New Jersey, just one will electrify more cranes and more straddle carriers, getting rid of diesel, good for air quality, right? Good for the neighborhoods, excellent. We're going to electrify approximately 400 to 600 megawatts, or 1 nuclear plant's worth of electricity in one facility. And so this whole idea of absorbing transportation, someone 150 years from now is going to look back and go, you know, the dead dinosaurs were bad for the environment, but they made a mighty powerful fuel source, because you are running in your car something that is incredible. You don't always appreciate how powerful a car and a car engine is, and with one human sitting in it all the time. But as you try and electrify it, and you look at the electric density you need to do the same thing, you appreciate it, because it begins to add up very quickly. And so that also will have intelligence as we look for vehicles to begin to share power. Already we're seeing schools that are looking to do electric buses. Those buses will now roll out at night to do football games and others, so you get rid of the gensets, the diesel, you know, wonderful smelling engines that run for the food stands. The buses will serve as emergency, so they can roll into places and provide 4 or 5 hours worth of power when you need lights and things. And so they're going to be hooked up to solar arrays. We're beginning to rethink how this transportation system becomes part of it, because remember, the model today says we're going to put it in your house, right? You guys are going to buy electric cars, you're going to buy chargers. How many people have a gas pump at their house, private? Okay, that's nobody, including nobody watching, I'm pretty sure. And so you're changing the whole model now, and right now your house kind of uses this much electric, right? Now you want to use this at night. How many people get home at 5 to 6 o'clock at night? How many people are going to plug in their cars at 6 o'clock at night if they all get home? You do realize in about 12 minutes, all the lights in this room are going to go out if that happens, right? Everywhere. And so we have to think through how the absorption of that happens, and how intelligence, right? Intelligence in the power system gets there. And I'm going to talk about Nest and a few things in a minute. One last thing that I want you all to think about, as we think about charging and energy density, one thing that's also interesting about vehicles. Today, a garbage truck in a town and a place like Hoboken goes out and it picks up garbage, and it shuts itself off for like 20 minutes. So you know what happens if it snows right now? They put a plow on the front of it, and it goes right back out. If you're charging for 4 hours or 8 hours for each truck and each vehicle, you got to think about the uses and how often then that vehicle gets used. Do you need more of them because it's got to charge and you can't just keep going, right? And so all that gets built in as well, as we begin to rethink the dynamics, including how you physically plug them in. The buildings that the vehicles are stored in don't have energy capacity today. They were built as storage places. They have a couple of heaters and a light. If you start to plug in cars, those buildings are going to be gone. And so we have to rethink that, right? And this is, of course, the last part. It's the beginning of how we rethink the interconnection, and I know this is a lot on a slide, but it is the interconnection, the interoperability between what I view as the many sectors of government and government light. Hospitals are not all government, but they are government light. They operate in a similar way. They have networks. They're interconnected by rules of government, and they're required for emergency services. Schools the same way, water treatment, right? Garbage pickup. I don't think most people realize that when a storm hits, FEMA's primary responsibility is to get the government working. Because if you think about it, right, just to pick up the garbage, it takes the government to contract to pick up the, right, it takes operations. You got to begin police and fire and rebuilding roads, and all of it relates to government getting operational. And when government has no operation plan, they can't turn things on, they can't charge their phones like you, right? Well, they're sitting there with nothing, not a computer, not a laptop. There was nothing here, no power. I want you to think about arriving on an emergency and you have no laptop, you have no phone right now. How many people truly, if I pulled your phone during the middle of your trip with its GPS on, could get to the place you were going to, right? And you're all smiling, even your own home. I'm like, oh man, I haven't done this in so many years. I hope I get there. But it's this crazy interconnectivity, interoperability, and it also connects some things that we don't like to talk about, and you can see some of them. Wastewater plants, when they shut down, they put raw sewer into the water. It has dramatic effects on beach, quality, water, river, treatment plants, all sorts of things, economic activity. If Sandy had happened in like early in the summer, and the shutdown of the beaches would have been for weeks, right? The Jersey Shore would have shut in all of August. This plant shut down, guys. When the Passaic Valley Sewer Authority's plant shuts down, all 1 million people going to the bathroom, it goes liquid into the river, then into the ocean. It goes right down along the Atlantic coast where you swim. And so we would have shut the beaches down for that. It would have been another $1 billion punch in the gut, right? And so all of these systems are interoperable and they have to talk to one another. Today they have no intelligence and they're operating on single strings of hair that power them. And so tomorrow we're going to be hardening them. We're going to be rethinking about this. We're going to make that one-way highway I talked about a two-way highway where intelligence comes in and we begin to really think about it. And you know, I added this slide not to confuse matters, but to just give you, this is, anybody know Woodbridge, New Jersey? This is it. It really is. And so I looked underneath Main Street in Woodbridge, and underneath it, they're going to open it up 28 times in the next 10 years to do interconnection of gas and water and wastewater, and we have smart systems, and I'm trying to get in with a microgrid, and we've begun to rethink that this linear development, right, the intelligence I keep talking about, running next to water, running next to wastewater, understanding how all of the people, right, what's funny about roads and all this infrastructure is it leads right to the houses and the buildings, right? Everything is located alongside of these roads, right? And so we have no intelligence. You have streetlights running next to roads. What's under the road? Well, you know every time they lift it, right? Because traffic gets really bad, right? They're all separate lines. Have you ever seen it? Like, here's the gas over here, here's the water over here. And then I love the repave 2 weeks later to get the gas again. If anybody's laughing right now, they've seen it in their neighborhood where you got the street done, and there it is, oh my golly, they broke it open to redo a gas line that couldn't have been coordinated. And so we have begun to work with mayors all over the United States, California, Texas, Rhode Island, rethinking how the government's role in allowing people into its streets and allowing development through zoning. And think about master planning, right? We can change the dynamic. I can have a building built tomorrow, standard. When I build it tomorrow, it'll have a 30-year life. If it does, you will go over your 2050 goal because the building will be there for 30 years. It will have gas infrastructure because that's what's being built today. Will it have a Home Depot gas stove? Yes, it will. Will it have a gas dryer downstairs? It will. And who is throwing that out voluntarily for greenhouse gas purposes? No one. And so we have to begin to rethink how it is that we look at our building, our footprint, how towns zone and plan for infrastructure. If you extend gas to a development, what happens? It goes on gas, right? Is that what you want? Great, it's your decision, right? But people don't realize it's happening months and years before. What's sitting under Hoboken? High pressure gas. Do people have gas stoves? How many people? Right? Think about it. How many people have electric stoves? 1, 2.5, 3. Okay, right. And that's probably representative, call it 10%. And so it's this interesting thing. You can solar, electrify, but you have gas stoves. And so there's a gas network. We have to think about what that means. I'm not saying that's wrong, that's right. It is a decision you didn't make. You showed up and infrastructure had been approved. And so we're going to back up just a little bit, right? We're going to begin to rethink at the planning level as we're redeveloping. As storms come through, people say it's a disaster, really. Anybody been to Chicago? You know what happened after Chicago burnt down? It's architecturally a pretty city, right? Because they were able to rebuild gorgeous buildings, right? And do things that were interesting and different. The same has happened after Sandy in a lot of places. Smart places looked at it and said, we got to rebuild. We're having massive fires. Infrastructure's changing. We are going to have to pick up and back up from some of these rivers. We see it, right? Don't care what the belief is and why it's happening. Not my thing. It's up to you guys for that. But the reality is happening, right? And so while we're picking up, Why don't we do it intelligently? Why don't we require all of the infrastructure to work together? Why don't we require towns and cities to force a conversation where no one opens a street without understanding why, right? If we're going to repair gas lines, they stay for 30 years, right? And every time you pass one on the street, know that it's not going anywhere for a while. I'm not saying that's wrong. I'm not saying it's right. What I'm saying is that we don't often think about this level of interconnectivity between our levels of infrastructure. The wastewater goes into a pipe from your house. It goes to a wastewater plant. How's it run? Well, it's run on gas. It has huge demand. Well, then that means it's your gas, right? You're causing it. You're the impact. The water treatment plant, it's under your house, right? Well, we're off the grid. No, you're not. The water comes to your house still. How does the water get there? It goes through pumps, really, and the pumps are driven by, electric, right? It's not pure gravity. Even with the water towers, it doesn't go with pure gravity. So this is part of the thought process that I think is beginning to permeate, which is cities are getting involved. This is why when people adopt climate plans and things like that, it's truly about, okay, let's get major infrastructure, major projects, huge redevelopment, which is the money, thinking about utilities and water and wastewater, and thinking about opportunities, including communication that goes with it. One last thing. We're getting smarter. Many cities are going away from having infrastructure in a single pipe here and there. They're putting in huge conduits, fiberglass, waterproof in segments, and so 5G can go in, and you know what happens when 5G is obsolete, which will be in the next 5 years when I'm back here, and someone can just pull it out. Instead of digging up Washington Street, you pull it out and re-snake it, right? We're beginning to rethink about how we don't have to rip up, because as we harden and we back up and we create this more solid infrastructure, the last thing we should be doing is then ripping it back up so you can add a wire, right? And so we're going to get smarter because it's our money. And this slide is really about people say, well, how do you pay for it? Guys, we are paying for it now, every day. You count the number of trucks over the next 5 days you see rolling from every utility. Count them. And there's a number involved in that, and you will see it's a big one. This is what I was talking about. Towns are taking a more proactive view of the world. They're looking at planning. They're beginning to control their linear development. They are beginning to think about, and I want you to think about this campus, right? If we created a redevelopment and we were redoing, 14th, right up by the viaduct here, and we were to say we wanted the most efficient we could be, we're going to have solar, we're going to have storage, we're going to have on-site microgeneration that captures the heat right off the engine, so it gets to like 80% efficient. Well, if we began to have redevelopers think about how to take technology, and instead of running just a series of air conditioners that you see everywhere, put in central systems. Instead of running standard chillers, run thermal absorption chillers. They can actually cool using heat, right? And so I can run an engine to make power, and the heat, which would normally be vented, gets turned into air conditioning. It gets turned into heat. I don't need gas for the boilers. I don't need extra heat or extra power for the air conditioning. I get more efficient, and I begin to shield from the grid all of that dirtier power. This is the idea of shrinking the footprint, thinking about how mechanics and engineering and land use and planning come together so that you build things. And people look at me all the time like, well, it's complicated. We did this with parking. We did this with parking already. People said, you guys have nighttime use and the train is daytime use. Why don't we do some shared parking around the train station? And around New Jersey, New York, Connecticut, we have these transit villages, and people park in the train station at night when the parking's open because it's open for the restaurant. It was not, people look at it and it's a shared use, right? It's the beginning of thinking of how assets play off one another, and I'll show you a slide at the very end. This is way too much, but this is, again, this idea of cross-connectivity, right? Smart cities, smart services, the different reactors that are taking place. And one thing I'm just going to use this slide for because it talks about economics. This is the sort of Nest moment, and I don't know if you know Nest, but if you have a Nest, anybody have a Nest? It is a thermostat. It's a really fancy thermostat. You can talk to it. It's very cool. But it's the beginning, right? So I said power was a commodity. And I would dare you to tell me right now exactly how much you're paying for power. Okay. Does it get more expensive between 2:30 and 3 o'clock, yes or no? Oh my golly, I'm in trouble. It does. Absolutely, right? And between 2:30 and 3 o'clock, how many people remember their wonderful school days? What used to happen? What used to happen? That's right, they let them out. I know. Everything goes on. And prices go because somewhere around 3 o'clock here, schools are still open, kids are home, everything's on. California's up, yeah. And so there's a supply and demand, and the charge is not the electrons, not what you're paying for the electron, but it's on the wire. You're being charged congestion pricing. So if you got on the turnpike at 5 o'clock and they charged you congestion pricing, or New York City over there where they like to, you would understand that, right? You would be like, wow, if I travel between this and this hour, I'm going to pay a lot more. If you sit in this room right now for 24 hours, the time between, say, 2:30 and 3:30, and say between 5:30 and 6, also think about that moment. Everybody's coming now, right? People coming home, office is still lit up. People on the West Coast are still working. You'll see these massive jumps. And every second, power is measured for real. And it's really not just the cost, as I said, on the electrons, but the distribution system. And so that expense is driving people to rethink how it works. And what I love is in the energy world, people don't know what they pay for it. That's why I said, if you walked in to buy milk, it's $30 at 3 o'clock. You would understand that. But the same commodity here. And do you think the school adjusts? This is the smartest school ever. Do they adjust classes for peak here? Do they adjust them anywhere? Do big companies? Yeah. Do manufacturers? Yeah. Do shift breaks happen at big union shops during peak hours? Absolutely, right? I know companies now that have large engines that will shut 4 days a year, including some of like the Friday after Thanksgiving, not to give the folks off, although they do get off, because they can run the engines and sell the power back to the utility when they don't have anybody there, because there's so much demand for electricity at that time, it's worth a fortune. And so we have to get smarter. And what the slide is really about is the intelligence is coming. You don't have to get there. You all have your phones. The Nest system sits in your house, and I want you to picture this. It sits at your house, and there's a highway this way, which is electricity, and it's moving at the speed of light, and it knows how much it costs, right? There's intelligence to it. And a half a second, and it's actually a tenth of a hundredth of a second, before it gets expensive, it knows. It sends a signal to the line that peak is coming. If there's intelligence to read that, then the equipment, the control, the Nest, the thermostat, the intelligence can react. It can literally send a signal in your house right now and say, oh, they forgot to unplug the chargers. They're still in the wall. Just think about it right now. How many of you have one in your wall? Okay, she's using power right now through your peak. And so it sends intelligence instantly and says, oh, hold on. And it's moving fast, very fast. And it's going, refrigerator, hold on. No pump, stay cold, but don't turn on your compressors, right? Dryer, washer. If you're on, put it in hold cycle. Air conditioning, don't come on for a couple minutes. And if you go into a supermarket, if you've been to a shop right around here recently, you'll hear it. We're dimming the lights to save the planet. The intelligence in its control is reading that a peak is coming, it's aware, and it's beginning to shed load quickly because it knows that the best way to do this, the best way to save greenhouse gases, carbon cut, is reducing that power. Why? Because that power is the dirtiest power there is. It's when we need the most. When we need the most, we call up every source. Do you think the last sources of power are clean that we call up? I just want you to know, they're not really clean. They really are disgustingly dirty, dirty, dirty. But so that we don't have brownouts or blackouts that we used to have, and for people who remember brownouts, you were in your gym and you'd hear, and the lights would dim, and if they were the old bulbs, they'd shut off for 15 minutes and have to be reheated. That doesn't happen as much as it used to. It still happens because of this whole idea of keep pulling power, right? And so we're going to add a lot more intelligence into the system. We are going to get smarter about how things work, about how connectivity works. You can see this happening already as cars and bikes. Has anyone used the bike application or the scooter application? You can see that that's already tying GPS to your phone, to intelligence and billing. It's beginning to get there. And yes, cybersecurity is an issue. And yes, we're going to be on it. And yes, in 1982, people said, you can't have a Mac card because everyone will get your money. How many people have a Mac card? Great. I always tell people, how many people have actually had a fraudulent credit card bill that they were forced to pay? Raise your hand. I found one. Oh, you didn't go. Oh, I was going to say, I can help you. I have a good lawyer. Okay, and there it is, right? It is the securities that get built in. Over time, there is always the scare of what happens. And will it happen? Yes. Are you going to stop the technology from coming? No. Will you get more intelligent, and will distributed generation mean more points? Yes. Will more points maybe be more secure than having single points? Maybe. right? Intelligence is a funny thing. And so all of this becomes interoperability. The different pieces talk. They live under the street. From now on, when you walk out of here, I want you to think about what's under the street, right? The water, the wastewater, the gas, it's all moving underneath you. If you had a three-dimensional picture of what you're walking on, you would be freaked, totally freaked out, because you're all walking on gas that's moving at incredibly high speed. So it's the beginning of this. And you can see this happening live, right? Pittsburgh, and anybody who doesn't understand Pittsburgh, is one of the greenest, if not the greenest city in America, with its wonderful Paris Accord. And they're beginning to put intelligence into the streetlights. It's running in a microgrid. The streetlights they literally have micro pins that come in that allow 5G to come in through the streetlights. It adds intelligence because now the streetlights can turn on and off. They have color to them, which I will tell you the funniest thing is people install LED technology. I'm sorry, you guys have some LED technology. Anybody see what's on the wall over there? For those who can't see, it's a standard switch that goes up and down, right? Standard $1 switch. How much intelligence is in that switch? So the LEDs up there are the smartest lights in the world, and what are they attached to? Right, so they can't do anything, right? They can stay on, or they can go off. All a variable switch, all even on Alexa, but a Nest or anything else does, is it sends the signal, it adds intelligence, instantly lights change, things go, and by the way, they sell your data, so if it determines that your refrigerator is not working well because the motor's not working well, Home Depot sends you an ad 2 minutes later about your refrigerator. It's all coincidental. So intelligence is being added to a lot of the cities. Places like these are getting smarter. It's happening all over, and I remind everybody, this is the same fight. Thomas Edison's Chamber of Commerce is right down the street. He started it literally a couple miles down that way. And so we're back to small, right? We always had packaged distributed systems. We're shrinking. People are thinking about how greenhouse gases, how carbon, how footprint, how energy, how resiliency all really boils down to having smaller, more intelligent systems that are controlled in part at the local level, so you get a better ability to control your destiny. You all have been reliant on utilities, and you're in PJM, which is called Pennsylvania, Jersey, Maryland, which is your ISO. None of you probably know what an ISO is, but if you do, it's actually where your utility actually sits, and they make the rules. And somewhere in a basement in Pennsylvania, literally it goes down multiple floors, best place to watch the NCAA ever, biggest TV you'll ever see. They make calls every day about who gets called up, what kind of power, how dirty, how clean, where it comes from, and you sit with no decision making. You have no intelligence in the house to allow you to really control things. You don't really know the cost of it, yet it is the most critical thing that you operate on every day as I'm sitting here looking at computers and people looking at me on screens. And so one other thing I wanted to bring to everyone's attention, mostly because it's a super cool project, again, happening here in Jersey. One other thing we do very strangely here is we have a lot of power plants that are either waste-to-energy plants or other small plants, and they're connected to the grid. They make power in a neighborhood. Their impact is to the neighborhood. The trucks go through the neighborhood, but the power goes up into the grid, and it's actually sold, and most people don't know this, when you have a power plant, you're selling power at incredibly small prices, and I'll use an average price to give you 2 cents. By the time you buy it, it's around 10 cents. And what you're paying for is the transmission and taxes and security. But in many cases, the power is literally being made, like in this case, like 1.5 miles over that way, right? And you can see them along the turnpike. There's these little incinerators, little burners, little power plants. They're at Merck. They're at different locations. The one in Camden exists. And so what they're beginning to think about is how their impact could be reduced, how they could use water from the sewer plant that was it's gray water, right? It's post being treated, goes to the power plant, how the power could go to the sewer plant so that they never run out of power. And then eventually what will happen over time is the power plant will disconnect itself from the big grid and begin to go into the small grid. That is the difference between the transmission system, the big wires, and the distribution system, which are the small wires. The big wires are intended to move massive power long distances. But when they get here, they get stepped down. If not, it would blow your house up and your school up because it would be very powerful. And so we step it down. And what they're looking to do is to, instead of actually drawing power again to actually create power in the distribution system and use the small wires to help power a little area and shield it from the transmission. And when the transmission system needs help, they will actually help produce power up for the first time. And this is beginning to change Tesla, batteries, solar storage. Houses are beginning to think about, how could I use maybe 500 houses during the day when you're all away? Maybe I could activate them all at the same time, drain the batteries that were solar charged, and use them for the grid, because New York at 3 o'clock really loves power, right? So does this place. But people are not really home, right? Except for kids. And so it's a good opportunity as you start to see this, people are beginning to rethink how to bring power local and how to bring intelligence local, not just bringing it under the streets, but actually physically producing it in neighborhoods at a large scale. This is something you guys know. Everybody in the world is figuring out how to monetize this stuff. Companies are selling greenhouse gas offsets. People are trying to buy zero energy. Every mutual fund in America is trying to figure out how to get something green wrapped around it. You're seeing specific investment funds dedicated to water and wastewater. You're even seeing, we have a stormwater authority here for the first time ever, where towns can go ahead, form an authority to charge people for the stormwater that runs off. That's right, the rainwater that runs off the building. Why? Because I want you to think about this. The rainwater runs off the building. If you guys have cars parked here, and you do, they're producing oil, right? There's going to be some sheening. You'll see some color in the water, right? That water will go into the sewer, correct? It will go to the treatment plant. Does the treatment plant now have to treat the oil in the water before it can reject it into the water? Yes. So who pays for the treatment plant treating it? The taxpayers do. Everybody. But is that fair? What if you have a giant parking garage with buses and you're putting a lot of wastewater in because you have a huge surface lot and it's a lot of oil, and I have a tiny house and I don't even have a car outside, by the way? Should I pay the same? Why is my tax bill the same? I'm not here to answer. Just beginning to tell you that people are rethinking impact, right? Societal impact on how and who pays for what. And as you'll see, everything has been socialized in a way that you don't see it. The second you bring it back home and start to look at it and go, wow, that's the cost of gas, electric, water, wastewater, wow, that's a cost. You also get to see the profit. This is the last, I think, of the slides, which really talks about, as I said before, it's this whole idea of interconnectivity, interactivity. One thing I do like about this that I think people miss about the movement, in addition to adding the intelligence between all the process, it also does something else, right? It gives an unbelievable opportunity to use that intelligence in ways that better, right? And what I mean by that is there's a lot of people with lots of data, but that data is not information. I have lots of data. What do you want my data for? I'll give you as much as you want. The information you need out of this is, how do I better? How do I do it more efficiently? How do I make it smarter? How do I avoid traffic, right? The Waze system, right? Waze is taking a lot of information and it's presenting specific data that you want to know, which is, how do I get from here to here in the most minimally invasive way possible? These smart cities are going to begin to add that character to all of this, right? To how it's not just gas stations, but it's intelligence about which gas stations. It's not just pharmacies, but intelligence about which pharmacies. All this is going to go on at the local level. You're going to see decision-making happen on how you get through a town, what towns are able to do. You're going to see decision-making between the levels of government happen much quicker now. And what I mean by that, it's not the day-to-day bureaucracy. I can't help with that. It is really the ability for us to take all the information that we have as government, and one more time, we're not just the government we're the county, we're the state, we're the local, we're the sewer, we're the water, we're the electric, we're the hospital. In some counties, we're even zoos, right? I mean, truly, government owns a tremendous number of assets, and all of it is, the intelligence, all of it is left in these buckets. And so you can't get there if you're going to change power and transportation. You're going to back up for global warming. You're going to change infrastructure in a huge way. You're going to move power plants off the land and into the ocean, right? Offshore wind. This requires a tremendous amount of rethinking, and what would be awful, as I close on the good news, it would be awful if we got to a place where we did all this work, did all this re-infrastructuring, pulled up all these streets, and did not take the time and effort to add the intelligence that will get us to a place we've got to get to. Because at the end, I can't make decisions unless I have the data, the right data to make it. So I want to stop and leave 15 minutes for Q&A and end with saying thank you for having me here tonight, and I look forward to taking any questions you may have. Thank you.